Hey all, Math 6, 4.4 polygons in the coordinate plane. Alright, so the vertices or endpoints of some polygon are 3, 3, 3, negative 4, negative 2, 3, and negative 2, negative 4. We're going to draw that. Okay, so this is skill number 1 for the day. We've got to draw these polygons. So 3, 3 over 3, and we go left or right first, and then we go up or down, right? So we're going to go right 3 because it's positive 3, and then up 3 because it's also positive 3. 3, negative 4, I'm going to go right 3, and then down 4. Puts me right there. That's right 3 and down 4. Okay, starting in the center again, negative 2, 3. Got to go left 2 and then up 3. And then lastly, negative 2, negative 4. Starting here, we're going to go left 2 and then down 4. Okay. So we've drawn it. Now we can go ahead and connect our vertices. And what have we created? A rectangle. All right, so got to be able to graph those. I think you guys are probably fine, so let's keep on rolling. All right, let's do a little distance calculating. We're going to calculate the distance from 3, 6 to 3, negative 5. So first thing we got to do is graph. All right, so let's graph the point 3, 6. So right 3 and then up 6. And then right 3 and down 5. Now to calculate that distance, it's a simple matter of counting, but you might be saying, well, hey, you got some negative numbers in there. Does that affect the counting? No, it does not, because I'm asking, what's the pure distance? How many hash marks are between these two? So let's just start at the top one. You can start at the bottom one, doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The distance is 11 units. Alright, so let's check out this problem. An architect is drafting plans for a pool. Okay, the pool is going to have the following vertices: 0, 0, 0, 50, 70, 0, and 70, 50. What is the area of the pool going to be? Alright, so we got to graph these vertices, but we need to realize something. Both of our axes here are going in tens, okay? They're going by tens. And let's say it's feet, okay? It's feet in both directions. Okay, so how would we graph 0, 0 if these are going by tens? Well, 0, 0 is easy. It's still going to be right there in the bottom corner, okay? But 0, 50, if this is 10, then what would that line be? Have to be 20, 30, 40, and then 50. So the point 0, 50 is actually right there. 70, 0, got to go, well, right 70. So 10, 20, 30, 40, 50, 60, 70... 40, 50, 60, 70 right there, okay? And then 70, 50, go over 70 and then up 50, right there. Okay, so that is the shape the pool's going to take on, but they didn't ask us for what the shape is. They said, what's the area? The area. So I'm going to go ahead and connect them right here real quick, obviously forming a rectangle. And what is the area of a rectangle? Formula: length times width, or base times height. So I would say that's probably a good length right there, and we said if that goes by tens and that goes all the way over 7 times, that it's 70 times a width of, well, if it's going here and go up, how many times? 1, 2, 3, 4, 5. Each one's worth 10, so that's 50. All right, now these are two really nice numbers to multiply because we just multiply the 5 and the 7 and 35, and then there's 1 0 and another 0, so we add 2 zeros. And we are done. The area is going to be 3,500 feet squared. All right, so here's kind of a neat problem. All right, so I've already graphed 3 points, and of course, you know, we've talked about this. You guys need to draw a x-axis and a y-axis on your graph paper that you're taking notes with. And we're going to name 2 coordinates that could be graphed in order to form a parallelogram. So we've already got these 3. So what would be the other 2 coordinates we could graph? Well, we could think, well, man, it really looks like this is the parallelogram being formed, and then so maybe something over here and up. Okay, that's fine. So what would it be? Well, if we go from this point to this point, it's down 3 and left 2. So if I go down 3 and left 2, that puts me right there. And look, we've got a parallelogram there, okay? But guess what? It's not the only way, all right? What about if you kind of take the whole thing, and I don't know if this is even going to work, probably not. Spin it, yeah, see, it's not going to work like that. No, that's unfortunate. You kind of spin the whole thing, points included, to the right a little bit. Okay? And what I'm seeing is that, hey, what if this isn't the base down there? What if the base is like right there? Which would mean the other base would have to be out here somewhere, right? Okay, so where would it be? Well, how do I go from like this to this point? I go 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. So let's start here. 1, 2, 3, 4, 5, 6, 7. 1, 2, and 3 right there. And then look what I've got. Parallelogram going that way. So that was one way, and again the other way was going, saying go 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. You could also go that way. They're different parallelograms, but they're formed using those original 3 vertices. Either way will work. All right, hey y'all, that's all I got. I will see you in class.